Bonjour. Alors, malheureusement, il me faut présenter en anglais. Mon français n'est pas assez bien pour présenter ces topics en français, malheureusement. So, I will continue and start in English. And this one, where do I have to click? No? You start my presentation? Okay. So, how AI is revolutionizing e-commerce? No? Again? No? Ah, peut-être? Non? Okay, so, well, as long as we don't understand how human intelligence works, we cannot build artificial intelligence. Now, is this guy right? I think he's not. It is much easier to construct a car than a horse. And when the car was introduced, nobody knew how to build a horse. But nonetheless, in every means where the horse was the dominant means of transport before, it has now been replaced by the car. So you can improve something you do not completely understand. You can build something that fulfills the purpose better. And this is the case for artificial intelligence nowadays. We all are using artificial intelligence every day. I think all of you have a mobile phone, and on the mobile phone you have things like Siri, where you can dictate, and the mobile phone will understand or at least recognize what you speak. And this has been possible only by artificial intelligence, by huge advance in neural networks around 10 years ago, the deep neural networks, or convoluted neural networks in this case. Before that, researchers have worked about 20, 30 years on understanding speech, and it has not worked. A friend of mine has done his PhD in this around 2000. It has not worked. It works only since, in about 2007, there was a revolution in the way of neural networks, and all the previous ways of understanding speech were replaced by an AI approach with artificial intelligence. Another common thing which happens every day, but none of you normally works directly with it, is the stock market trade done by computers. And in fact, computers trade about 10 times as much stocks as people do. And this is also something that improves rapidly with artificial intelligence. So money rules the world, and AI will control that flow of money that rules the daily stock market price. But this sounds trivial because we can do it on our own. Can computers do things that, can artificial intelligence do things that most people cannot? And yes, that's also true. They can be very creative. Now, this is a picture of the nice city of Tübingen in South Germany, and Tübingen was never painted by Vincent van Gogh until now, because researchers of the University of Tübingen have fed a neural network hundreds of pictures painted by Van Gogh, like this one, the night sky, and they have told the neural network to paint pictures like this. And here we go. This is Tübingen. So you see, the church is there, the tree on the left-hand side is there, the river is there, it reflects the houses, everything works well, and this is what AI can do nowadays. It can emulate creativity. It is not creative on its own, but it is kind of creative. It learns how people do things. It may do it in a different way, but the AI replaces creativity done by humans. So, when we take a look at all those things, how do they work? Generally, AI is all about probabilities. So if you have simple decisions, if you have simple tasks, normal, ordinary software can do it much faster and much better than artificial intelligence. Only when it comes to difficult decisions which need probabilities, things that are uncertain, things that have a number of input variables and nobody can really explain how to use those input variables to predict something, AI comes into place. And What AI can do much better than conventional software is predict something, predict a result out of a number of input variables. And based on these predictions, what you can do is you can take decisions. And the combination results in much better, in a much better result than conventional software did. Now, how do people make decisions? I give you a simple example of a bank loan. So somebody goes to a bank and wants a loan from the bank, wants some credit from a bank. And what happened in the very past was that there was a bank manager who just looked at the guy, maybe looked at the information he had, and said, well, this guy or this woman looks trustworthy, I grant them the loan. Nowadays, this does not happen normally. It's based on data which is calculated by a computer to predict whether somebody will pay back. And for this, a programmer has taken a number of variables like those and put them together with a financial mathematician who did the work on the probabilities, put this into an algorithm which then calculates out of those variables, calculates will this client probably pay back or not pay back the credit. So like if you have the job, the occupation of being government employed, you will get like plus 50 points, and if you're self-employed, you will get like minus 100 points or something. Those things are put into algorithms by a programmer. This can be replaced by a computer today easily, and computers are now quick enough to make this viable. You would use algorithms like multivariate regression or decision trees, which are quite understandable algorithms, not as complex as neural networks, and you can do exactly the same as the financial mathematician did for the programmer. The software automatically calculates the probabilities based on all those input variables. Now, what is the advantage of this against the bank manager taking his or her decision on their own? Or what is the advantage even of this one, of the man-made algorithm? So it's more reliable, so you know how it works, and people can explain why a certain decision was taken. Whereas in like 50 years ago, it was just the bank manager's whim, and he might be on a good mood or on a bad mood. But now with this kind of algorithm programmed by a programmer, it means that you can rely on it. When you do the same with a multivariate regression or with some kind of simple algorithm, you also have a record of what was the basis of the decision on a certain day. But this can change every day, because that's the advantage. The multivariate regression can do this every week, every day, maybe every minute, can recalculate based on new cases and learn. It can learn from the cases. You give it like 5,000 credits that were paid back, 1,000 credits which were not paid back, and the algorithm will automatically decide how to weigh the factors, how many points to give for the occupation. State employed might be not plus 50, but today only plus 42, because it gets less sure that you will always keep your job. Now, the advantage is that it can do this every day instead of only like every year when the financial mathematician and the programmer sit together. The disadvantage is you don't know beforehand, it changes every day, and so it's not as reliable. Now, when we come to more complex algorithms like a neural network, this can handle more difficult situations. As you can see, I can probably go this way. As you can see, there is another layer. So I showed you here, there is just the input and the output. And here we have another layer. It's called a hidden layer. And neural networks today have many hidden layers, and also many more of those nodes in the layers. So it's not only 2 and 5, it's like maybe 300 or 700. If you give it too many different nodes, it will just learn things by heart rather than generalize decisions, so it cannot predict new situations as well when you give the neural network too many nodes in between. Now, what the neural network will do is just the same as before, so it learns from the output. It takes like 5,000, 10,000, 100,000 credit cases where credit was paid back or was not paid back, and then tries to optimize its parameters by experimenting with changing them. And then the new thing is that there are hidden layers, and it has to learn 2-step or 5-step or 20-step. And the advantage is that because of those hidden layers, because they're all connected, you can see, so all of those layers in the second, of those nodes in the second layer are connected to every one of the 2 input nodes, and that's normal for a neural network. It can handle interdependencies between the situations, so somebody who's self-employed and earns a lot of money and does this for quite a while might pay back his credit quite well. Whereas the previous approach just took each single, only one dependency here on the income or the occupation, and they were not interacting. With a neural network, they can and they will interact, and so you can the neural network can learn much more complex combinations of factors automatically. You don't have to really do something by hand. You don't have to understand how to solve the problem. You just give it the input factors and it will learn automatically. What is the disadvantage? So somebody says? Exactly. You don't know how to explain the results. It's not something you understand, and especially when it gets more complex. So like this is a typical neural network today. Still much too small. There would be many more nodes in between. Even if somebody would try, it would take them years to find out why a single decision was taken. And what neural network does in between is it builds some kind of abstractions. So when you as a human recognize a face, you might remember something. Your brain might build up something like he or she has long hair, a short nose, big eyes, those things. And these are also abstractions you build. And all those factors together make the face, and you recognize this person. And the computer does the same here with a neural network, but it might build completely different abstractions we don't understand. So it might measure things like what is the angle of the eyebrow, or what is the length of the eyebrow hair, or those things. So it could be completely different things, or it could be things I cannot even explain. So this is what neural networks do here, and they build those abstractions, and you cannot trace back how the neural network decided. Okay, the next one. So in general, there are to just clear up a little bit of the confusion with all the words. The definition I rely on is artificial intelligence is everything that emulates human intelligent behavior. Machine learning is when the computer also optimizes on its own. So it takes its own results, learns from this, and then improves. And it's deep learning when you get into these unexplainable, like neural networks or the deep random forests or other technologies like this. Also, 2 words to know and understand is supervised learning and unsupervised learning. So supervised learning is when you teach the computer. Unsupervised learning is when the computer can experiment on its own. And that's like children. When children learn, they experiment on their own. And when you have a small child, who has children? Okay, only a few, but I think more. And when you remember when they were very little, they threw things from the table, and then things dropped, and the child was ha ha. And then Mummy put back the spoon on the table. The child put the table back, the spoon back again on the ground. It fell down again, and the child was happy again. So why? Because the child predicted that this will fall down to the ground. It predicted that it will make a sound, and those things are positive feedbacks. The child was happy, and it learned something. Children are learning machines. And this is the same way what now neural networks are starting to do. Of course, they are by far not as evolved as children are. Okay, so with these new technologies, what we can do now is we can also handle complex situations, not only simple and complicated situations. Simple, everybody can explain. Complicated, an expert can explain, the financial mathematician. And complex situation is something where you can't really explain, you don't know how to do it, and you can still handle this now with artificial intelligence. Okay, so what does this mean for e-commerce? You all know recommendation engines. Who bought this also would buy that. Personalization, different customers get different results for a search or for a click. And thus they buy in between 10 and 20% more. Then semantic relevance of keywords in search. This is one of my patents, but it's also done by other things. So you search for milk and you don't want to find milk chocolate, you want to find milk. And so the semantic relevance has to be evaluated, and this can be done automatically without that the computer understands what milk is. It just takes the relevance of certain attributes to the product. So also adaptive pricing. So you have different prices at different times or even for different customers. All this is today also already possible, and many e-commerce shops are doing this. So what is going to happen in the next years? One is semantic search, and for this we will do an experiment. So you will be the search engine, and I will give you a text and a search phrase, and you have to search. Okay, and here is your first text. And this is your first search phrase. Now, can you find it? Who has found it? Nobody yet? Yeah, some have found it now. Okay. So, as you can see, this thing is here, for example. It's also part of this. And now the important question here is, did you understand the text? Did you need to understand the text in order to find it? No, you didn't. And that's how conventional search works. Conventional search just looks for the pattern of the letters and tries to find the combination of letters that makes the word. It does not understand the word. Now, here's the second experiment. Here's your second text, and here's your second search phrase. Okay, who's found it? Yeah, okay, some. It's the Ferrari. So the escape vehicle is the Ferrari here. And now the question again, did you need to understand the text in order to find the search phrase? To find the answer? Yes? Yeah, so everybody nods? Exactly. And that's how semantic search works. It needs to understand, and when it understands, it will respond rather than just find the words. And this is not finished yet. So people are working on it, Google is working on it, many others are, but it's not, this will be still very difficult, this kind of question here. But many other things can be found. And it will come in the next years. So semantic understanding is also necessary to participate in a communication. This is chat commerce, and chat commerce is not very common in Europe. People are using chat, but they're not using chat commerce. But in China, over 50% of the smartphone owners have already bought at least once on WeChat. So this is very, very deep. If somebody's interested, we have made a study on that. We don't have it here on our stand, but we can send it to you on how WeChat works in China and how this could influence European e-commerce. So another kind of chat is direct voice chat. Who's seen the Google video? Can we maybe start it? Listen. Sound? Okay.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around?
So what you hear here is a chat between somebody who wants to reserve a barber's date at a barber's shop on the phone. And one of the two is the computer. Who? Who is the computer? The caller or the barbershop? And it's the caller. And you heard that the caller said, mm-hmm. And people said, oh, Google is trying to fool us, and Google is building those things like mm-hmm in to make people think it's a human, but Google wants to fool us. I don't think so. I think the software automatically analyzed millions of conversations on the phone and discovered that people say mm-hmm in this case. And thus, it uses this. It's not built in on purpose by Google. Okay, can we continue? It's just another, like, do we have like time for about 5 or 6 slides? Oh, okay, continue. We rush. So if we can't finish, then come to our stand. I can show you the rest of the presentation. Okay, will soon everything be voice commerce? I say no. Voice commerce is coming, but it will not be. It will not replace traditional online shopping. Why not? Because choice is parallel and voice is sequential. So when you utter something in a voice, if you hear something, it goes one after the other. Whereas when you choose something, you want to see, you want to combine, you want to compare. And thus, if you want to have choice, you need a screen. And voice commerce on its own, just an Alexa on its own, will not do it. What can be done is, oh, sorry, it's not here. So So if you combine voice with an AR device, augmented reality, then you will get back the information, and this combination could work. But voice on its own will not work. AR, on the other hand, has many implications for shopping, but not for online shopping. We've done some research on that. I've held not a presentation, a workshop on this on an UX conference. We can discuss on this in the breaks later on. Another thing is, AI can replace traditional shopping behaviors. So this is predictive basket, another one of our patents. Predictive basket is something where you get the full purchase you want to make today when you enter the online shop. So normally when you shop for groceries, for toilet paper, for jam, you have to choose every time, and when you buy 30, 50 things, it takes half an hour, 1 hour, until you have everything in your basket. With predictive basket, we analyze the shopping behavior of the single customer and of all customers, and predict what you will buy today, and present this to you. And you just say yes, 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 no, no, yes, yes, yes. Okay, I think I have to end. Okay, so facial sentiment analysis, we can discuss on this later on. Ambient supply, we can discuss on this later on. But in the end, it's the customer who decides what they want, and you should be you should be doing those things that make customers' life easier. Then you sell more. Thank you very much.
Thank you very much, Carsten. Thank you very, very much for your time.